Welcome, travelers, to Adventures in Security. In this video, we explore cloud business continuity management, including disaster recovery. You can download the video script, including the bibliography, from the link in the description. In this video, we will treat resilience as a management discipline, not simply a storage or infrastructure problem. That distinction matters because cloud outages, cyber incidents, provider dependencies, and configuration errors can interrupt revenue, operations, compliance, and reputation at the same time. We will begin with the people and roles that make continuity planning work. Then we will clarify the difference between business continuity and disaster recovery, review the traditional planning model, and explain how cloud adoption changes that model. After that, we will walk through what a business continuity management program should look like for infrastructure as a service, platform as a service, and software as a service. We will then examine cloud backup and recovery options, including their strengths and limitations, and finish with testing and training. The core message is simple. Moving to the cloud does not eliminate continuity planning. It makes that planning more shared, more technical, and more dependent on disciplined governance. A cloud continuity program succeeds only when it has clear ownership. The executive sponsor sets priorities, approves risk tolerance, and resolves conflicts between cost and resilience. The business continuity manager coordinates the program and keeps planning artifacts current. Business owners identify mission-essential functions and acceptable downtime through the Business Impact Analysis, or BIA. Technical leaders then translate those business priorities into recovery architectures, backup strategies, and restoration procedures. In cloud environments, the technical team usually includes a cloud architect, platform or site reliability engineers, security operations, identity and access administrators, network engineers, and the personnel who manage backup, logging, and key material. Support functions are also critical. Legal and compliance address regulatory obligations. Communications handles internal and external messaging. Procurement or vendor management governs contracts and SLAs, and the help desk supports users during disruption. NIST's cloud reference architecture also reminds us that recovery may involve cloud consumers, providers, brokers, auditors, and carriers. In other words, continuity in the cloud is an ecosystem problem, not a single-team problem. Students often use business continuity and disaster recovery as if they mean the same thing, but they are not identical. Business continuity is the broader discipline. It is concerned with keeping critical business functions available at an acceptable level during and after disruption. That may involve alternate workflows, manual procedures, temporary prioritization, or degraded service. Disaster recovery is narrower. It focuses on restoring the technical environment, systems, applications, data, network connectivity, and supporting infrastructure. NIST frames contingency planning as a coordinated strategy of plans, procedures, and technical measures for recovering systems, operations, and data after disruption. It also emphasizes that recovery may involve alternate equipment, manual processing, or an alternate location. Incident response is related but distinct. Incident response focuses on detecting, containing, and eradicating malicious activity, while recovery focuses on safely restoring operations and learning from the event. So the relationship is best understood as a hierarchy. Business continuity is the umbrella. Disaster recovery is the technology restoration component. And incident response is the discipline that manages the active security event before and during recovery. The traditional continuity model begins with two foundational questions: what must keep operating and what happens if it does not? The business impact analysis answers those questions by identifying mission-essential functions, their dependencies, and the impact of downtime. Risk assessment then considers the disruptive scenarios that threaten those functions. From there, the organization selects recovery strategies. NIST describes several classic approaches: restoring information systems with alternate equipment, shifting some work to manual processes for short-term continuity, or recovering operations at an alternate location for longer disruptions. Those strategies are then documented in a structured plan set that typically includes continuity procedures, disaster recovery procedures, communication steps, contact lists, escalation paths, and recovery objectives such as Recovery Time Objective, or RTO, and Recovery Point Objective, or RPO. Traditional programs also rely on test, training, and exercise activities, so the plan is not just written, but operational. The important lesson is that continuity planning has always been about aligning business priorities with technical recovery methods. Cloud changes the implementation details, but not that fundamental logic. When organizations move to the cloud, they do not outsource continuity. They redistribute it. NIST defines cloud computing as a model with on-demand access, resource pooling, rapid elasticity, and service models, such as SaaS, PaaS, and IaaS. CISA's Cloud Security Technical Reference Architecture builds on that by emphasizing a shared risk model for cloud adoption. CSA likewise stresses that both cloud service providers and cloud service customers have distinct but interconnected continuity responsibilities. In practice, that means continuity plans must address dependencies that are less visible in traditional environments: identity providers, cloud control planes, infrastructure as code pipelines, managed services, regional architectures, provider retention settings, and API-driven restoration workflows. The organization also has to validate what the provider actually guarantees in its SLA versus what the customer must design and test independently. Cloud resilience is therefore more architectural and contractual than many legacy programs expect. The planning question is no longer just, where is my alternate site? It is also, what exactly fails over? Who controls it? What data state is preserved? And how do I reestablish trust in the restored environment? Infrastructure as a service places the largest recovery burden on the customer. Under the NIST definition, the customer provisions core compute, storage, and networking resources and retains control over operating systems, storage, and deployed applications. That means the continuity program for IaaS must look very much like a modernized data center recovery plan, but automated and cloud-aware. Critical workloads should be architected across failure domains, such as multiple zones or regions when the business impact justifies the cost. The recovery plan should protect not only application data, but also machine images, block storage snapshots, network configurations, DNS settings, secrets, logging pipelines, and the infrastructure as code templates required to rebuild the environment. One of the strongest IaaS practices is to recover by redeploying a known good stack from code rather than relying only on manual restoration. That reduces drift and accelerates trust reestablishment after an incident. Because the customer owns much of the stack in IaaS, the most important question is not whether the provider is available, but whether the customer can rapidly and correctly reconstruct the workload it depends on. Platform as a service changes the recovery boundary. NIST defines PaaS as a model in which the customer deploys applications using provider-supported languages, libraries, services, and tools, while the provider manages the underlying infrastructure. That sounds easier, but it creates a different continuity problem. The customer may not need to rebuild servers or operating systems, yet it still must recover its application logic, deployment artifacts, environment variables, configuration settings, access controls, database schemas, and data state. For many organizations, the continuity weak point in PaaS is not infrastructure restoration. It is application redeployment and configuration correctness. A strong PaaS continuity plan therefore protects the source repository, CI/CD pipelines, secrets management, database backup strategy, and any dependencies on managed services. For highly critical systems, the organization should decide whether it can redeploy in another region or whether it needs a second live or warm environment. PaaS reduces some infrastructure burdens, but it does not eliminate the need to test whether the application can actually be rebuilt, reconfigured, and revalidated under pressure. Software as a service often creates a false sense of safety. Under the NIST definition, the customer uses the provider's application and generally does not manage the underlying infrastructure. However, the customer still owns the continuity of the business process that depends on that application. That means the SaaS continuity plan must go beyond the provider's uptime promise. It should examine data retention, export capabilities, administrative recovery, support escalation, legal hold requirements, and any limits on restore scope or timing. The organization must also protect tenant-specific configurations such as roles, identity federation settings, workflow rules, dashboards, reports, and integrations with other systems. In many SaaS environments, losing configuration can be almost as damaging as losing data. For critical platforms, many organizations add third-party backup or export controls so they can recover from accidental deletion, corruption, ransomware impact, or provider-side limitations. The key lesson is that SaaS reduces operational burden, but it does not remove accountability. The customer remains responsible for continuity of use, continuity of access, and continuity of the underlying business outcome. A practical way to group cloud recovery options is by how much they preserve, how fast they restore, and how independent they are from the failed environment. Snapshots and point-in-time restore mechanisms capture a recoverable state of storage or databases and are usually the fastest for operational rollback. Backup copies sent to object or archive storage are typically more cost-efficient for long retention and granular recovery. Replication maintains a second copy in another zone, region, or even another provider, which can reduce data loss exposure. For SaaS, export functions or third-party SaaS backup tools may be needed because native recovery can be limited by provider design. Finally, disaster recovery as a service, or DRaaS, extends beyond data backup and aims to restore both data and supporting IT infrastructure in a third-party cloud environment. CSA explicitly describes DRaaS as a model for backing up data and IT infrastructure so organizations can regain access and functionality after a disaster. The takeaway is that backup is not one thing. It is a portfolio of mechanisms that should match the organization's recovery objectives and risk profile. Each backup option carries a trade-off. Snapshots are useful because they are quick to create and quick to restore, especially for operational failures, but they may remain tightly coupled to the same cloud platform or account structure. Traditional backup copies stored in durable object or archival storage are economical and support longer retention, yet restoration can take longer and may require more orchestration. Replication is powerful when the business cannot tolerate much data loss because it can drive a very low RPO. The drawback is that replication may also copy bad data, misconfigurations, or malicious encryption if detection lags. Cross-region, cross-account, cross-cloud, or immutable copies improve resilience against regional outages, account compromise, and ransomware, but they add cost, governance overhead, and testing complexity. DRaaS, or warm standby models, provide the fastest path to restoring business services because infrastructure and orchestration are already prepared, but they are usually the most expensive and require disciplined maintenance. The right design should follow business impact analysis and recovery objectives rather than a one-size-fits-all rule. Critical services may need layered recovery, while lower priority systems can accept slower, cheaper methods. Plans that are not exercised are assumptions in document form. NIST defines a test, training, and exercise program as a way to ensure personnel know their roles. Plans are exercised for viability, and systems are tested for operability. A mature cloud continuity program uses several levels of validation. Walkthroughs and plan reviews confirm accuracy. Tabletop exercises test decision-making, communications, and roles. Technical drills validate that backups restore, identities recover, automation works, and dependencies reconnect correctly. Where the risk justifies it, failover and failback exercises provide the strongest evidence that the environment can actually recover. NIST recovery guidance stresses the value of realistic test scenarios, and CISA's tabletop exercise materials provide templates for planners, facilitators, participants, and after-action reporting. Testing should measure more than technology. It should assess whether the organization met RTO and RPO targets, whether leadership made timely decisions, whether vendors responded as expected, and whether restored systems were trustworthy. Every exercise should end with corrective actions, owners, and deadlines, so testing becomes an engine for program improvement rather than a compliance ritual. Training must match responsibility. Executives and crisis leaders need decision-making training, escalation thresholds, regulatory concerns, communications, and business prioritization. Business owners and continuity coordinators need training on business impact analysis, manual workarounds, dependency mapping, and recovery objectives. Technical staff need hands-on training in restoration procedures, identity recovery, cloud-native logging, infrastructure as code, backup validation, and failover execution. Security teams need to understand how incident response transitions into recovery, including when restored systems can be trusted again. Support teams such as the help desk and communications staff need scripts, alternate contact methods, and user support procedures. End users should also receive basic continuity awareness, including where to get instructions, how to report issues, and how to operate under degraded conditions. NIST's TT&E model is useful here because it ties training directly to roles and responsibilities, while CISA's exercise materials reinforce defined roles for planners, facilitators, evaluators, and participants. The final lesson is straightforward. Cloud resilience is not achieved by buying a service. It is achieved when governance, architecture, backup design, testing, and human performance all work together under stress. That's it for this video. If you learned anything, please remember to give us a thumbs up and subscribe. And until next time, be careful what you click.